Today's lesson is lesson number 5, which is I can build and interpret tree diagrams. So a tree diagram is one way to figure out all of the possibilities that you might have. And if you can't figure out our blanks, it says a tree diagram is a way to organize and calculate probability. And those are our keywords. We are going to organize all of our possibilities, and then we can also calculate all of our probabilities, which is really important, especially for your upcoming project. Example 1 states that on our sticker chart for the probability summative, there are 2 learning targets. Okay, so we have our 2 learning targets, PO8 and CO4. There are 8 different colored stickers to pick from. They're down below. How many different ways could a student put up their sticker? Well, I have 8 different stickers that I could put down for my first option. And I have 8 stickers to pick from for my second option. And so that means I have to figure out what to do with my 2 8s. And so when I want to think about this, for PO8 and then CO4, I could do red and red. I could do red and purple. I could do red and green. I could do red and light blue, and continuing on. I'm going to get so many options by just starting with red. And then I have to start with purple and go through all the options again. And then I have to start with green and go through all the options again. And so we are going to multiply these values together to figure out our answer. The total number of ways is 8 times 8, or 64. If I multiply all of the options for part 1 times all of the options for the other thing, it gives me my total possibilities. Example 2 says the Smith family has game night every Friday and Saturday night. The family either plays a card game or a board game. And we're going to draw a tree diagram to show out all of our possible outcomes. And so what we need to do is we need to list our events. We're going to have event 1. Event 1 is our Friday night game. And on Friday night, we could choose a card game or we could choose a board game. So those are our options for that first night, Friday night. Then our second event is on Saturday night. On Saturday night, I can choose a card game or a board game, but it needs to be the tree diagram mapping. So if I chose a card game Friday night, I could choose a card game on Saturday, or a card game Friday night, and I could choose a board game on Saturday. And then we're going to go ahead and do the same for if I started with a board game Friday, I could then play a card game, or if we did a board game, I could then play a board game again. So those are all of my options for the second night or the second event. And then finally, we can list our outcomes. Now, our outcomes is following that map that we've created. So we went CC. On that branch, it was a CC outcome. Then my next branch, CB. My next branch, BC. And my last branch was BB. These are all of my possible outcomes. I have 4 outcomes, which is right because on my first event, Friday night, I had 2 options for everything. And on Saturday night, I had 2 options. So altogether, I had 4 ways I could pair this together. My outcomes are all the possible combinations that I could play between Friday night and Saturday night. These lines that I'm making purple are those tree branches on our diagram. We are making a giant sideways tree when we create tree diagrams. So we always want to leave lots of space on event 1 so that we can squeeze in event 2 and possibly event 3. Now our next question says, what does an outcome of BB represent? Well, I know BB was a board game Friday night. Board on Friday night, followed by a board game on Saturday night. And then it said, what did CB represent? Well, CBC is card. It was a card game on Friday night and a board game on Saturday night. The order these things happen can also matter, so keep that in mind. Now, going back to our tree, it says circle the outcomes in your tree diagram where one board game was played over the weekend. One board game could not be a BB outcome. So we could have had a board game and then a card game. Or we could have had a card game and then a board game. We couldn't have done card, and we couldn't have done board because that's more than one. Okay, then it says, what is the probability they'll play exactly one board game? Well, we have two options of when that happens. So it was 2 out of 4 times, which I know is 1/2. That's my probability. My next question says, Miss Morose and Miss Rather both have 3 girls. What is the probability that you would have 3 girls from 3 separate births? Make a tree diagram to show the probability. And so we need to start with event 1. Event 1 was our first child. Our first child could have been a girl or a boy. Then we need event 2. Event 2 was child 2. So we could have had a girl followed by a girl or a girl followed by a boy. We could have a boy followed by a girl or a boy followed by another boy. And then event 3 is your third child. So from everything in event 2, we need to branch out to all of my options. My possibilities are boy or girl. So from each event 2, I need to branch to girl or boy. So I'm going to have lots of branches, which is why I needed to make sure I spaced out everything accordingly. Okay, so I had 2 outcomes for each time. I had 2 outcomes here, 2 outcomes here, 2 outcomes here. So all together, 2 times 2 times 2, I should have 8 grand total outcomes. And we like to list those outcomes. It could have been a girl, 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 boy. Remember, when we're doing this, we're following the branches. Girl, 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 boy. Then girl, boy, girl, girl, boy, boy. So let's add those. Girl, boy, girl, girl, boy, boy. Then we keep following those branches. Boy, girl, girl, boy, girl, boy, 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 girl, and boy, boy, boy. So this is our tree diagram showing all of those outcomes and all of our probabilities. There's 8 outcomes, so each event, each outcome happens 1/8 of the time. Okay, all of these represent 1/8 because remember, if I add up all my probabilities, they need to equal a whole, like we learned yesterday. So 1/8 times 8, 1/8, 8 times is that 1 whole. So these all have equal chances of happening. So what is the probability for each outcome? 1/8 of the time you could have any of these outcomes. So that means that if we want 3 girls in a row, the likelihood of that happening is only 1/8 of the time. And then lastly, it says, how can we determine the number of total number of outcomes without drawing that diagram? Well, we know we can multiply all of those possibilities together. So I like to use a sandwich. If I want to make a sandwich, I have 2 types of bread, 3 types of meat, and 4 different cheeses to pick from. That's a really, really big tree diagram to make. I'd have a lot of branches. But if I have 2 times 3 times 4, 2 times 3 is 6, 6 times 4, I know I have 24 different sandwiches that I could make. We could draw a tree diagram to show all of those different sandwich combinations. But if we don't have to, it saves us some time.